This is example 9.4 from Discovering Design with Chemistry. A chemist is doing the following double displacement reaction. They've given us the equation. They've told us what kind of equation it is. Doesn't really matter right now as long as we can read the equation. If the chemist starts with an excess of MgCl2, so magnesium chloride, and 150.0 milliliters of a 2.0 molarity solution of AgNO3, silver nitrate, how many grams of AgCl should precipitate out of the solution? All right, so let's look at what we've been given, and then let's look at what they're asking for. So we've been given that this is an excess, so we have extra of that. And we've been told that we have 150 milliliters of this solution. So 150.50 ml. We're probably going to have to convert that to liters, so I have no idea why I added a 5 to the bottom of that. This is why I have to check my work because I'm very careless. ml to liters. We'll use it if we have to, but if not, we'll leave it there. All right, and then it also tells us that it is 2.0 molarity. That means that there are 2 moles per liter, or whenever we have the molarity, we have moles per liter. So we will definitely be needing the liter thing. All right, and then it asks us how many grams of AgCl, so we want this one and we want it to be in grams, should precipitate out of the solution. So let's go ahead and get started on some of our work. So we know we're gonna change this to liters. So we have 0.1500 liters. And usually when we're doing these, we know our path that we've taken in the last chapter. We would start at grams, we'd change it to moles, we'd work in moles, usually converting from the moles of one thing to the moles of another thing, and then we would convert that back to grams. So this is still similar. We're starting with our AgNO3 and we're heading towards our AgCl. The problem is that we weren't given grams or moles, we were given milliliters of the solution, and then how much of that solution is actually the thing we're looking for, the concentration. So we have the concentration and we have the volume. We can figure out what part of that solution is the substance that we actually care about. So if we rearrange this so that we can get moles, we take the molarity they give us, multiply by the liters, and that will give us the moles that we need. So let's plug in what we have. We have 2 for that, and liters is 0.1500, and I could put moles per liter, and then liter, those two would cancel out, and that would give me moles. All right, so whenever you're doing this, again, make sure that you are careful to keep your significant digits. Your calculator may give you 0.3 or 0.30 if you do it in your head. You just need to make sure that you keep the thing that matters. So this has 2 significant figures, so that's what we're going to stick with. Okay, so now we know how many moles we have of the first one. Because this one and this one, the 2 things we're working with, both have a 2 in front of them, we know that however many moles of AgNO3 we use, we're going to have the same number of moles of AgCl coming out of it. You can do the conversion, and in fact let me squeeze this up a little bit. In fact, in the example in the book, you'll see that we have 0.30, and this is moles of AgNO3. So, and because we are using NO3, that's moles, we can say that for every 2 moles of AgNO3, we get 2 moles of AgCl. and then we would cross out the things that are the same, and we would do this multiplication. But if you notice, this is going to cancel out, leaving us with just a 1, and so we're still going to get 0.30 moles of the other one. And so if the two numbers, I mean, it's good to keep doing it so you don't forget to do that step. But if you're working to go from one thing to another thing and you notice they have the same number in front of them, they both have a 2, that means the number of moles that you're using of one is the same number of moles you're going to get of the other. So I'm also going to have 0.30 moles of AgCl that are going to come out of this thing, because if I put in a certain number, I get that same certain number because the 2's are the same. All right, so because I have that many moles, now they want me, I can go back to where I'm going. What do I actually want to get out of this? I want to get grams. So now I just need to convert my moles to grams. So we do that the same way we've always done. Well, always meaning the last chapter or so. We figure out how many grams there are per mole of AgCl. So this is a little bit small. So we can add those numbers and figure out what our, actually let me just leave them circled, it won't hurt anything. So if we add those together, because AgCl has 1 of each, we can just add 107.87 plus 35.45. We get 143.32 AMU. And so that number tells us that that's how many grams would make up a mole. So for 1 mole, we have 143.32. And so we can multiply that number by the 0.30. And that will tell us how many grams of AgCl that we're having, that we're getting out. So we only can keep 2 significant figures, so we're going to round that to 43. So for this, we're going to get 43 grams. So that's how many we have up here, is 43 grams, and that's the answer, 43 grams of AgCl. So the one thing I probably didn't point out at the beginning is they pointed out that we had an excess of something, and the reason they said that is because that tells us that we are using all of the AgNO3. So far, all of the problems that I've looked through as I've gone through the book have mention of this, and so it's just to make sure that you understand you're using all of it. I haven't seen a problem where you're not using all of it, of either thing, and then you have to figure out which one is the limiting agent. So it may come up later, but it hasn't so far up to chapter 11, which is where I am in my reading. If you have any questions about this one, especially if you don't understand how we got from one to the other, this is really just combining what we did in the last chapter, where we took our little path from grams to moles, and then moles to a different moles, and then moles to grams. That little path, the map on the page that had the picture of the literal little cartoon moles that looked like it was traveling down a road. That whole thing that we did, all the stoichiometry last chapter, it's taking that and then it's adding on top of that the concept of concentration and this molarity idea, where you have moles of your solute, the thing that you're dissolving, in the liters of the solution that is created by dissolving it in there. And so it's just taking these 2 different formulas and concepts and mashing them together in one thing. So if you make a plan, see what you have and then what the problem asks for, and then take these 2 concepts, you can put them back together